Good morning, everyone. This is the last part from my side of the lecture on berry development. It's part 3. What I aim to share with you is, while representing results about the dynamic of compounds accumulation, is the difference between representing results on a per berry basis, milligram per berry or gram per berry, and in concentration. This is the classical curve of berry growth. You already know it, with the green growth stages, veraison and ripening. It is the growth curve of a population of berry. Then if you look at the accumulation of tannins, you will see that the tannins are accumulated before veraison. You will see as well that the tartaric acid and the malic acid are accumulated before veraison as well. So the first message is that you have some very important compounds which are accumulated before veraison. And practically speaking, it's really crucial because it means that if you think about ripening, to me, and it's not a joke, ripening is not starting only at veraison. You have to care about the canopy management and cluster of fruit zone microclimate from pea size onwards, because during the green growth stages a lot of very important compounds are accumulated in the fruit, and they are accumulated before veraison and not after. So as I said, as example, we speak here about tannins, and organic acids are as tartaric acid and malic acid. The other message is when we represent results on a per berry basis, it's irrespective of the volume of the fruit. And this is explaining why from veraison onwards, as the fruit is increasing again in volume, you see that the quantity of tannins per berry is stable. The quantity of tartaric acid per berry is stable, irrespective of the volume. Now, if you look at the malic acid is decreasing. Why? Because, as you know, malic acid is used for berry respiration when the berry is accumulating sugar. And as Charles Romieux will explain to you, one malic acid is used for the fruit to accumulate 4 exoses. So the compounds like malic acid, which are used for metabolism from veraison onwards, of course, they see their quantity per berry decreasing, because obviously they are used to do something, to achieve something. And as you already know from berry softening, the fruit is accumulating sugar and anthocyanins. You see that the biosynthesis of anthocyanins within the skin is parallel to sugar accumulation. It's not there is no direct relation. It's just that anthocyanins are accumulated in parallel of sugar accumulation. And in a lot of situations, we saw that when the sugar per berry reaches a plateau, then for many reasons, the biosynthesis of anthocyanins slows down or stops. As I said, it's not a direct relation, it's a fact. And for anthocyanins, you will see that in some situations at the end of ripening, you can have a decrease of the quantity of anthocyanins per berry because they are used for some metabolites. It's possible in certain situations to see a decrease per berry of tartaric acid if you have a precipitation of tartaric acid in the vacuole of the cells, mainly in association with potassium. That can happen. Normally, here my curve of the evolution of malic acid is not perfectly exact, because Charles Romieux will explain to you that when the sugar per berry reaches a plateau, normally all the malic acid has been respired. So the lowest quantity per berry of malic acid corresponds to the plateau of sugar accumulation. But wait for Charles Romieux explanations, he will speak about that. That's quite important. Okay, let's speak about the evolution of compounds per concentration. And you see here that now per concentration, the volume of the berries will matter. Let's look at the evolution of tannins, which are done before veraison, which are accumulated before veraison. And because from berry softening onwards, or a little bit after berry softening, you have an increase of the volume of the berry, now in concentration you have a decrease of the tannins. So it does not mean that the tannins are used to do something in any kind of metabolism. It is just, or there is no catabolism of tannin. It is just a matter of dilution. Same applies for tartaric acid. And obviously for malic acid, now it's a complex equation between dilution and respiration. Of course, from the berry softening onwards, veraison, you still have the accumulation of sugar. In parallel, you have accumulation of water, so the volume of the berry or the berries will increase, and you have the biosynthesis of anthocyanins in the skin, as I already said. So with two simple, I will say, figures, and using some really important targeted compounds and doing some kinetics, because it's important to understand what is going on during berry growth and ripening. It's important to do kinetics. I suppose I did convey a few important messages about the dynamic of berry growth and the evolution of its composition, or the evolution of the composition of berries, sharing with you the difference between in berry, milligram per berry or gram per berry, which is irrespective of the evolution of the volume for the accumulation of compounds, and in concentration, where now the volume of the fruit will matter. So this is the end of the part 3 of my lectures on berry development, a bit on berry composition, and the next lecture, for the next lecture, I will speak about sequential harvest, fruit and wine composition, and wine styles. And for that, I will share with you some results I got when I was in Australia. So see you soon. Keep well.